Alright, welcome back to our daily Leetcode challenge. Today will be the 26th stage of our commitment, and the Leetcode problem is the total waveness of numbers in range 1. I hope there is no 2 coming tomorrow. So we're given it two integers, num1 and num2, represented inclusive range. Num1 and num2 inclusive. Let's say we're given like 1 to 10. So we have to consider the number from 1 to 10 inclusive. So the waviness of the number is defined as the total count of its peak and valleys. So what do they mean by peak and valley? A digit is a peak if it is strictly greater than both of its immediate neighbors. And okay, that means the middle number is greater than the left and right. How about the valley? So if it is strictly less than the both of its immediate neighbor, the first and last digit of the numbers cannot be peak or valley. Also makes sense. And any number with fewer than 3 digits also have no waveness. So if the number is only 3 digits, so we cannot measure it is a peak or it is a valley because we only have 2 points. We have to return the total sum of waviness of all the numbers in range. So let's check their given assignment. Alright, so we are given like number from 120 to 130, 122, 123, 124, 125, 126, 127, 128, 129, 130. Cool, we are in the correct situation. Okay, in here, let's check what are the numbers. We can check like, okay, for the 120, the left and the right number is 1 and 0, which is technically smaller than our middle number 2. So we have to check only the middle number. So if it is middle number is bigger or smaller than left and right, we can take it as 1. Okay, then which numbers are greater? So we can see like in this one, 121 and 130. So that is the reason why we receive the 3 in here. Alright, it makes sense for that given assignment. So if it is not, we take it as 0. How about assignment 2? We are given like the very limited numbers. Let's consider like 198, 199, 200, 201, and 202. Okay, let's try to check our middle number is greater than the either of the left and right in here. So if I have to mention that, so I think this one and this one, this 2, because we can also see that as a valley. So let's see this as a 2 as a number. Let's see, we draw the graph from here like 0 to 1, and then 2 is like this graph, and 0 is here, and then we got like 2 in here. So this is considered valley because we are in between of the 2 huge, I would say, towers or something. A tower is a bad example here. Let's see 2 mountains. So we got like 3 for assignment 2 also. How about assignment 3? So for assignment 3, we have to check both middle number. How do we check both middle number? So 4848. Let's consider like 4848. Okay, this is better be the green number, and I will make it huge. And this number in here, we can do it like, let's check the 8 as our middle ground number, which is here. So since the 8 is greater than the left and right value, so we can count that as a 1. What if we move our ridge radius from here. So 4 is less than from the left and right 8. So we can also that count as a 1, and these two combined become 2. So that is how we receive the 2 in here. I think that is pretty simple, and I would say it's a dynamic programming problem. Let's consider like reset is 0, reset, and what I want to do is for number in num1 through num2, and maybe how about we create the helper function in here, since we don't want that number to use by outside of the solution class. Let's go Waviness. That is going to accept the number as input, and we return the integer. Alright, that is where our favorite things come in for our static programming in data type. I need to convert that number into string. So our integer becomes the string, and I'm gonna map it through with the array because we need each character in array, and then we can convert it back to the so now we are here the character, and then for the character I need to convert it back to the string so that we could able to convert back to integer, because in Swift we cannot directly convert from character to integer with one shot. And then there's the integer came in. Yep, that's how we do it, character to string to integer. So happy using the compiler language. And then we can do the one clause also if digit of count, maybe just do the count as always. We can do the one return directly in here. Count is should be the less than 3, because it is mentioned here fewer than 3 mean the less than 3, and we can directly return the 0. So we don't need to consider that because the number is only 2 digits. It doesn't make sense for us to consider the values or peak. Okay, let's go through from first to last index. Let's go index 1 through count -1, because I don't want to go all the way to n. And let's go left, which is going to be the digit of index -1, because index start from 1 and then 1 minus 1, it becomes a 0. And we got the middle, which is a digit of index, and we got the right. So that is the reason why I'm doing the -1 in here, even though we are using the less than sign in here of index +1. So if we don't put the -1 in here, that could cause the array index out of bound in Swift. Let's check its peak. How do we check the peak? According to the given practice here, peak mean it have to be like this. This is a one value in here is so huge, and one value here. So that means this is a peak. This is a peak, but that is a very ugly drawing. Middle has to be greater than left, and middle have to be greater than right. So that's the peak. How about its value? It's pretty simple. Middle is less than to the left, and middle is less than to the right. So if its peak or its value both are true, we can just okay, maybe how about instead of returning each time by time, maybe create that thing called wave count is 0, and we will do like wave count plus equal to 1, and then just return it. I think we can just use that number here. Number. Let's try to run locally. I forgot that in. Okay, something went wrong. What did I do wrong in here? Ouch. Instead of returning the result, I just returned the 0. What a silly mistake. Okay. I believe that is time complexity will be the O of maybe num2 minus num1 log num2. It's a little bit complicated because we are using the recursive in here to recalculate the numbers against and against. Then the memory will be the O of log num2 because we are heavily relying on the range of the num2. Alright, I hope you guys enjoying today's problem, and let's switch not to receive the hard question of this one. Hope you guys enjoyed this video, and I'll see you in the next one. Bye!